We now move ahead to a new area, and that is called exact equations. So we write a differential equation in one of its very common forms and see when we can call that equation an exact equation, and if it is not an exact equation, then there are certain processes of multiplying by integrating factors so that the resulting derived equation becomes an exact equation and is amenable to standard solutions. Now, the form that I am talking of is m dx plus n dy is equal to 0. This is a very standard form of writing an equation. Here, we must remember m is nothing but a function of x and y, and n also is another function of x and y. So, the form is m dx plus n dy is equal to 0, and we will call this an exact equation if the left hand side is a perfect differential. In other words, m dx plus n dy, if m dx plus n dy is equal to a perfect differential of a function of u, where u again is a function of x and y. So, this is d of u xy. If that happens, then the whole equation can be written as du is equal to 0. In other words, u xy is constant, and that is the solution to this particular equation when it is an exact equation. But most often than not, we will be faced with equations which are not exact, but they have to be converted to exact equations by the use of integrating factors. But let us see, if an equation is exact, how to integrate that to its solution. So, we will just take a bit of time to rub out. We will just write down the criterion for which m dx plus n dy is equal to 0 becomes an exact equation, and that criterion, it is being stated without proof, the proof is not being given, is the condition is as follows: the partial derivative of n with respect to x must be equal to the partial derivative of m with respect to y. This is the criterion for the equation to be exact. The partial derivative of n with respect to x is the partial derivative of m with respect to y. So, this is very, very important, and also gives us the rule to check out whether a particular equation is exact or not. In case it is exact, then the integration procedure to find a solution is as follows, and that rule has to be understood and remembered very carefully. I will write down the rule in detail. So, whenever we find del n del x is del m del y in m dx plus n dy is equal to 0, the process of integration is as follows: 1. Integrate this m dx with respect to x, keeping all y terms contained in m xy as constant. So this is integration with respect to x, keeping y constant. Actually, keeping is not the right word. A better word perhaps would be treating. Treating y as a constant. That is it. This is the first step. Second step is still very similarly, we integrate n dy with respect to y, keeping x constant. And the third thing to keep in mind is, in these two integrations, especially in the second, if there is any term which emerges that has come here in the first integration, that has to be ignored. So there is no double count allowed. So once again, integrate m with respect to x, treating all y's contained inside m as constant. Integrate n with respect to y, keeping all the x terms constant. And the third step we write here, put an asterisk here and write ignoring any term that has already appeared in the integration of m dx. So this is very important. So no double counts. That is the procedure to solve an exact differential equation subject to the criteria that stands for its verification. We now take an example of an exact equation which I have written down on the board already. This is our m and this is our n. So the equation is of the form m dx plus n dy is equal to 0. Now we see if del n del x is equal to del m del y, and if that is so, it is an exact equation. Now doing del n del x, we get 4, because we differentiate this with respect to x, it cuts to 0. And also del m del y similarly is nothing but 4. So the criterion for exactness is satisfied, because we said for an equation to be exact, del n del x must be equal to del m del y, and here it is. We must remember that that is a necessary and sufficient condition. That criterion, that del n del x must be equal to del m del y, is a criterion that is a necessary and sufficient condition. So having said that, we will now integrate the equation. First integrate this with respect to x, integrate this with respect to y, and see if there are any terms which are coming or being repeated. Such terms have to be ignored. Let's do the integration. So this with respect to x means 3x plus 4y plus 5, 3x square by 2 plus 4xy plus 5x, and this second fellow 4x minus 3y plus 3 dy is 4x y minus 3y squared by 2 plus 3y. But we must see that this fellow has already come earlier. So the 4xy term has to be ignored from here. So the solution will become this part add to this part is equal to constant. Because when we integrate 0, that was the term on the right, that is nothing but constant. Irrespective of what we respect or what we integrate with respect to. So this plus this term is equal to C is the solution, which is simple to write.